Well, welcome to this day 5 second session of this AICTE IST sponsored refreshers program on recent trends in signal processing RTSP 2022. Today we have with us Professor Sabyasachi Mukhopadhyay. He will discuss on the deep learning. It is a hands-on session rather. So I welcome Sad with a small token of felicitation. Sir, just a minute. Let me to share as it is a online session. So just I am sharing my screen. Okay, so well, sorry for the delay. This is a network problem.
Thank you so much.
Sir, please accept this as it is an online platform. So welcome to this 1 week refreshers program. This is from the organizing team. We heartily welcome you to this session. And now this session is over to Sandhya Madam for a detailed introduction of the SAR.
Thank you so much, sir. Thank you very much. I really loved it. Thank you.
Thank you so much, sir, for giving me this opportunity to welcome Mr. Sabyasachi Mukhopadhyay. He's such an eminent person that he doesn't need an introduction, but as the tradition goes, I take this opportunity. Mr. Sabyasachi Mukhopadhyay is currently working as Assistant Professor of Business Analytics in Postgraduate Management Studies at BIMS Kolkata, and being the champion innovator Cloud AI ML Google, he is also the Google developer expert in machine learning and Intel software innovator. Mr. Mukhopadhyay is involved in teaching of IoT at University of Calcutta as a visiting faculty and also at Symbiosis Center of Information Technology and also in Techno India University. He served as a university faculty of Business Analytics and Statistics at School of Management Science, Macau, and was the university course coordinator of BBA and MBA in Business Analytics in Macau. Mr. Mukhopadhyay was a project scientist at Nanoscience Technologies for a brief period of time, and he did his BTech in ECE from CEM Kolaghat in 2012 and has received MS in Physical Sciences from IISER Kolkata and was the topper of 2015 batch. He was the co-founder and chief research officer of Toilet MedTech Private Limited and currently involved in startup mentoring activities. He has more than 55 publications, which include patents, books, journals, and proceedings, and has received several international awards, which include Best Research Paper, prestigious SPI's Photonics Education Scholarship, Most Inspiring Facebook Developer Circle Lead twice, Best Supportive Lead Master Hacker Award, Alumni Award of 2020 by IISER Kolkata, and so on. He has also received several travel grants from SPI IISER to present research works in international conferences. Mr. Mukhopadhyay was on board as nominated board member and external expert of Institutions Innovation Council at IIM Kolkata, Techno India Main Salt Lake, and IISER Kolkata. Mr. Mukhopadhyay was also on board as an expert external expert of NISP committee at IISR Kolkata. He has delivered invited talks, served as panelists and judges of hackathons in leading IITs, IISER, NITs, IIST Shibpur, and many leading state and central universities of India. He has also delivered invited talks in foreign universities like University of Global Village, Bangladesh, University Kofi Annan, Guinea, Galposing College of Information Technology, Bhutan, and so on. Mr. Mukhopadhyay was invited to deliver talks in Atal AICTE faculty development programs of IEM Kolkata, CEM Kolaghat, and NIT Mizoram. Sir, we welcome you on behalf of the EC department to the AICTE IST sponsored refresher course on recent trends in signal processing. I request you to take over the session.
Thank you very much, ma'am, for your generous introduction. And thank you very much to the organizing committee for inviting me here. It's my all pleasure to be here. And thank you all for organizing this kind of the elegant refresher course programs. It requires a lot of effort. So I really hats up to all of your efforts. And really, also I'm requesting the respected participants to open kindly Google Colab. Just search in Google by typing Google Colab. You will see which is the topmost link coming up. You can just open it and open new notebook. Okay, so I will also show you that how to do it. So let me share the screen. So just a second. So you can see that I'm simply typing Google Colab. Okay, so once I am typing it here, you see the topmost option which is coming up as Google Colab. Okay, the link is given as colab.research.google.com. Just click on it. You may start by clicking on the new notebook. Okay, so one new notebook, a fresh notebook will come up where you can practice the codes. Okay, so you see that you can put some name like demo DL for practicing deep learning. Just give some name like that. Okay, and then you see there are two pop-up options are given there: plus code, plus text. So plus text, if you want to add some theoretical content or some instructions related to code, so you can do it by clicking on plus text. And by plus code, there will the one pop-up will come up here. Okay, and you see you can write the code here, and you see there is a run cell button indicator is there. You can click on those run cell button and you will be able to execute the code. So kindly be ready with opening this setup. So once I will post the coding materials in your chat box, so it will be easier for you to execute the code. You can easily copy paste from that, and you can just run it in your machine. So in your Colab, okay, which is basically playing the role of virtual machine. So just before starting with that, so we'll start with first with the data manipulation in deep learning. So before starting with that, those who know deep learning, don't need any kind of the introduction. But those who are new to deep learning, for them, just I want to share some of the background, how we have evolved to deep learning. 5 or 10 minutes it will take at most. So you see, basically from the 1940s era, when people started to think about the mimicking of the human activity. So it was all about mimicking of the human activity, and they came up with the concepts like the neural network.
Sorry to interrupt you,
yes.
sir. I'm very
yes.
sorry, but
please,
sir,
please.
The screen is not yet started sharing. I think we are not able to see the screen. Yeah, yes, sir.
Okay, just a second.
So if you could try again once.
Can you see the screen now?
Yes. Now it is.
Yeah, now it's
okay.
visible. Yeah.
Okay.
Yes.
Okay. Thank you. So this is, you see, let me go back again then, just to show you that where we have started. So
yes,
this
sir.
is
better
Google.
to start from beginning.
Now I think the screen is visible, right?
Yes.
So you see that in Google, I have typed Google Colab. So you can see the topmost pop-up option is coming up, Google Colab, which the link is colab.research.google.com. So kindly click on this link, Google Colab. Okay, so there you will be able to see there is a one new notebook pop-up is coming up at the button. Just click on new notebook.
No, sir, your screen is not moving. It is visible, but the page is not changing. It is not moving.
Everybody is facing the same problem. Can anybody see the page changing?
Sir, page no, it's not changing. No, sir, it is not changing.
Changing, I think, sir.
Not changing.
It
Not
is changing,
changing,
right?
sir.
Not
Not
changing.
changing. Not changing.
Not changing.
Oh, then to this is the problem going on there.
That may be due to the network also, sir.
Sir,
Okay,
share your entire screen.
Just a second. Let me share the screen again. Can you see it now?
Yes, we can see. We can see that collab research google.com. That is written.
Okay. So just a second. So I am moving to the next pop-up. Okay, so you can. I have opened the new tab. Okay, can you see the screen now?
Yes, you are writing something.
Google Colab. I am just typing Google Colab. So you see, can you see
Yes,
now
yes.
the changing?
Yes, yes,
What is
yes,
happening?
yes,
Okay,
yes,
now
yes.
it is sorted. Okay, so the link is given there. You can figure it out from the link as well, colab.research.google.com, or you can simply click on the Google Colab button. Okay, so you see that if you have the existing notebook, it will show. So as you are opening, you will try to open the new notebook. So click on new notebook button. Okay, is it visible to all of you? New notebook button. So you can click on it. So you will be able to see that new notebook is opening up. Okay, so can you see that? Is it visible? Can you please kindly confirm me, Sonda madam or Soman sir?
Yes,
Yes,
yes.
Okay,
Yes, sir.
okay, thank you.
The screen is visible. It is untitled 17.
Exactly. Okay, thank you. So what you can do, you can simply put some name, like edit the name, and you can give some name. As you will practice the code here, you can put some name like demo DL. You can do like that. Okay, and you see that there are two pop-ups are coming up here. One is the plus code, and another is the plus text. So you can click on the plus text in case you want to add some text or some instruction related to the code. You can add up there, and the plus code button you can click once you want to type some code or something like that. So what I will do, I will paste the codes in your comment box. So copy paste the codes in your comment box. So what you will do, you can copy the codes from there, and you can paste it in your Colab, and you can run it. So how can you run it? By just clicking on this run cell button. Okay, this run cell button, using the run cell button, you will be able to run the code. So I will show that gradually one by one. Just kindly be ready with this particular setup. You please open the Colab and put some name like demo DL for your practicing purpose. Okay, and then you will be able to run the code. So after once we have done it, so I'm just going back to my original notebook. So this is basically, we will start with the data manipulation first. So this is the original notebook. You can see these notebooks I will email to the organizers. So you will get a lot of the theoretical aspects as well. You can see that by clicking on the plastics button, theories are added there. Okay, and you see these coding sections are also added there. So just before we are starting our coding execution section, I am just giving some brief introductory part. Those who are new to deep learning, it may happen that those who are expert, they already know about it. But among the respected participants, there may be people who are new to deep learning. So just I am giving you the brief introductory part before we are starting the hands-on execution. So you see that in the 1940s era, it was the first philosophy of mimicking human activity came up, when people started to think about that, why not we have some sort of the setup which actually can mimic the human brain, the way we think, okay, and replicate the job. So basically, it was the main era where we started exploring the machine learning part by introducing the neural network concepts. Then gradually the theoretical development happened, and we have seen the rise of the computer science as well, along with this parallel concept of the machine learning. Because you see, even in all the developing countries from the late 1960s, they realized the need of the computers in every offices and every houses to store data. So gradually what happened that along with the government allocated the budget, and in parallel the research of the different programming languages started to goes on. So we have seen the procedure oriented languages like C, and then we have seen the rise of the object orientation. So first of the jump to the 1980s was C++. Then 1985 we have seen the pure object oriented languages like Java. Then in 1990s, what happened that we have seen the rise of the open source era. That is the main important thing in the open source era. The Linux Foundation played a very, very important role by introducing programming languages like R, then Weka, and also in the parallel, Python has been developed a lot. So these open source programming activities has given a lot of boost in the kind of the research and the educational nurturing in case of the developing countries. Because you see, due to the lack of budget in research, we have the problems related to the hardware accessibilities, but due to having this kind of the open source era, people started to explore the softwares freely, because before 1990s, whatever the softwares are available, those you have to buy. Okay, if you don't have the budget, you can't buy or afford those kind of the softwares, because SPSS was very much costly then, and other statistical supporting softwares like SAS and etc. was costly. And even till nowadays, it is not possible for everyone to afford SPSS. So you see that then what happened, that due to the rise of the R, Python softwares, people get some opportunity to explore the open source activities because it is freely available, and those who are the developers, they can contribute in the open source materials. Now, you see, in parallel, what happened, that the machine learning mathematical development was also started to explored in elegant manner, especially in 1990s when we gradually came up. In that time, support vector machine was very much popular, and if you see, Bapnik got the highest popularity because of that. He is one of the prime godfather of the machine learning, and early 2000, even at early 2000, it was in the highest popularity. If you see, we do, along with the decision trees, random forest, all the bagging and boosting algorithms, they are using frequently in different research papers. They are getting a lot of citations. But the thing is that although the deep learning was existing then too, in 1980s, the development of the mathematical development of the deep learning happened. And in 1988, it was basically the LINET. Ian LeCun had developed, and his team developed one of the deep learning architecture, LINET. But the problem was that you don't have it's not about the software development. Parallel, you require the processor supports as well. So in those era, you don't have the NVIDIA or the supports like TPU, GPU, you don't have those kind of the supports. So due to the lack of the support, LINET did not got the desired success. Even the performances of the support vector machine was higher than the LINET, because you don't have because what happened, the deep learning we basically use for the processing data in order of 10 to, whenever we have data in order of 10 to the power 5. Now, you see, in those areas, you don't have that much of the data, data processing support, data storing support. So LINET did not do well. And along with that, the most importantly, in those areas, when the LINET was developed, the activation function was sigmoid function. Okay, so ReLU-like function, use of the ReLU-like functions concept was not there. So that's the reason it miserably failed. But it gives us some ray of the hope that in near future, if we get the adequate processor support, hardware development support, and data storing support, then obviously deep learning can do some miracles. So it showed us some ray of hope. And in 2010, when Fei-Fei Li, one of the pioneer scientists in the computer science domain, he basically belongs to the Stanford University, and she also one of the playing a vital role in Google research. So she basically highlighted that why not to prepare a large data set, okay, for the ImageNet competition. So she is one of the main person who played a very, very pivotal role while launching the ImageNet competition, where you will store data sets. At least you have the data sets of data in order of 10 to the power 5, and you can try out your different deep learning architectures and see that whether you are being able to get some kind of the proper outcome or not. So once we started the competition, it was launched in 2012. So first, one of the great success which we have, that is the AlexNet, okay, and Geoffrey Hinton's lab got a huge success by launching the AlexNet, because then in 2012 they got the benefit of NVIDIA, because 2012 NVIDIA launched GPU, 2016 Google launched TPU. So nowadays we have the support of the GPU, TPU. Even the Colab we are using, we have the support related like virtual GPUs, virtual TPUs. So due to that reason, you see that although the mathematical development and premier launch of the architecture has happened in 2009, in 1980s, but we are getting the benefit of the deep learning from 2012 onwards, because once the deep learning got the acceleration in the development with the support of this GPU, TPU, it got a humongous success in terms of processing the higher dimensional data. And if you see that not only about the processor support, also people started to deal with the activation functions like ReLU, which got a huge boost in the deep learning algorithms, because you see, whenever you use the sigmoid function or tan hyperbolic function, these are not the performance wise scalable. Okay, if you see the curve of the tan hyperbolic or sigmoid, which we'll discuss very soon, we will explore the codes on them. these are basically has some limitations in terms of the performance or scalability. But deep learning has a ramp-like structure, ramp function-like structure in the activation function ReLU. So you can see that it is a performance or scalability, and that is where actually we started the philosophy of the superhuman activity, because behind the deep learning there was a superhuman activity philosophy was there, because in machine learning it was all about mimicking human activity. If even the activation function, like introducing activation sigmoid or tan hyperbolic, the philosophy behind that even if we are human, for all of human being, if we are working so much hard working, it is not possible for us to work for 24/7. We may work 10 hours, 12 hours, 14 hours, then our performance will be saturated. And that is how, because of the activation functions like the sigmoid or the tan hyperbolic, what happens that if you see the performance curve is optimizing gradually the performances, then it gives the saturations. So we may improve the accuracy gradually by training your algorithm 80%, 85%, 90%, then it may happen that your performance will be saturated. But in case of deep learning, due to continuous scalability of the ramp-like function like ReLU, you may achieve the accuracy even 100% as well. That is possible. Okay, so these are the basic background, that historical development of the very brief way, because we don't have much time. So I just told you very brief manner about how we have landed up in case of the deep learning present scenario. So we are starting with a very basic part, which is the data manipulation. Okay, so in the first step, what we have to do, we will use the MXNet framework of the deep learning. So first of all, I will send you this portion of the code to all of you. Okay, so in the comment box section, so please run this code in your Colab section. Okay, so let me send you that. So I believe that all of you can see my the code which I sent to you. Okay, so now I am showing you that, you see, this is how you will paste the code from your comment box section to your Colab window. Okay, and you see there is a run cell button option is there. Just click on it. So once you start clicking on it, you will be able to see that it is installing all the necessary frameworks and the nitty-gritty of other things. So you see NP is basically the NumPy which you are downloading. NPX is a NumPy extension. It will provide you all the necessary supports related to the deep learning executions from MXNet deep learning framework. Okay, so once the setup will be done, you will be able to see this running. You will be able to see this kind of the green tick button. Run cell will stop and you will be able to see this kind of the green tick button. Okay, so please let me know if you are finished with this particular portion, then I will move to the next part.
Yes, sir, it's done.
Okay, thank you very much, madam, for the kind confirmation. Now what we will do, we will see a very simple thing, that we are first generating the 10 integers. Okay, so you know the Python is a zero indexing language, so np.arrange, when you will do, it will start from 0, 0, 1, 2, 4, 3, 4, 5 up to 11, it will print. Okay, so we are simply generating a simple array. You just run it. Okay, so let me post it in your comment box section. Okay, so I think all of you may have been able to run it successfully. Just click on here. You see there in the button, you can see there are two options are coming up, plus code and plus text. Just click on plus text code button. Okay, just paste it and run the code. Click on the run cell button. So you'll be able to see that an array has been generated where the elements values are 0, 1, 2 up to 11. Okay. So kindly let me know if this steps has been completed. Have we been able to generate the array? I hope the screen is visible to all of you, right? Can anybody from the audience give me the confirmation that the step has been completed? Okay, so now what we will do, we will in the next step, we will see this. For example, you want to check the shape of the tensor. Okay, so how do you do that? You simply will click on x dot shape. Okay, it will give you the original outcome of the shape. Okay, so we are just starting with some basic examples, then we will gradually proceed to much deeper. So let me post this code in your comment box section. So now we are checking the shape of the array. Okay. So what you can do, you can just click on in the next to proceed the next portion of the code. You just click on the plus code section, paste it here, and just click on the run cell button. So it will give you the shape outcome. Okay, so you will get the desired shape of the array. You can also generate the same thing for example, you want to check out the size of the array as well. So how will you do that? So simply just write x dot size. Okay, and you will be able to see that the outcome, it will be printed as 12. Okay, so this is how you can generate the different attributes related to the array. Okay, like size, shape. Okay, so like you see, I am pasting it here also in the clicking on the plus code button. Okay, I am just pasting it here, and I will click on the run cell button. So you will get the output. Okay, so in this way, you can generate the things. Now you see, we want to reshape the whole array, for example. So how can you do that? So you want to convert this particular array, okay, into the matrix format. So you know that if tensor means multidimensional array. So in case of while dealing with the array, if this is a 1D array, it will take the scalar as the input. Okay, and if it is 2D array, okay, it will take the 1D array as their input. So in case of 2D array, you can understand that it will be matrix. So 1D array will be the input. So you have to reshape it first of all. So you have to put some row value, some column value will be there. So that's the reason what we are doing. We are reshaping X array as with 3 number of rows and 4 number of columns, because you see the row vector having the length of 12. So 3 into 4, 12. So we are dividing it into 3 rows and 4 columns. So if we do like that, that's the reason we are doing x dot reshape. Okay, 3, 4. So once we do that, so you'll be able to see following type of outcome. Okay, so just let me paste it in your comment box section. So I hope now you will be able to see the outcome. So this type of the following outcome will come up: 0, 1, 2, 3 in first row, 4, 5, 6, 7 in second row, 8, 9, 10, 11 in third row. Okay, so what you can do, you can simply paste this portion here. Okay, and you will be able to see the following outcome. Right, now let us explore some more things. For example, I want to generate, okay, a 3-dimensional array, okay, where you have the 2-dimensional array as an input. Okay, so what we are doing, we are generating the zeros, tensors with all the element zeros. So np.zeros 2, 3, 4. So once you do that, you will be able to generate that kind of the outcome. Okay, very simple. np.zeros. So you are generating the tensors with all the elements as 0. Okay. Run it and you will be able to see the desired outcome. Like for example, here I am again clicking on the plus code button. I am pasting it here. And once you can see, you can run the code, you can see all the elements are 0. Okay. Now you can do it the same thing for the np.1 as well. You want to create the new tensors with all the elements are 1. So how can you do that? You can simply write it as the np.1s. Okay, then you provide the necessary dimensions. Okay, and then you will be able to see the outcome like here I am doing. Okay, np.1s. So you see, this is the main, because I am not doing anything with this main notebook. Okay, because this is the original notebook. Now what I am doing, I am just showing you that how to run the code in some demo code notebook. Okay, So you can check it out from there. It will help you, assist you in the overall process. So let me paste in the comment box section as well. So this is np.1s. You just run it, try it out. You will be able to generate that new tensor with all the values 1. Okay. So now you can also generate some random samples as well. Okay. So to generate the random samples, what we have to do, we have to simply use, because basically you know that all the deep learning frameworks like TensorFlow, MXNet, PyTorch, Keras, these all are basically the highly Python based. So you will find a lot of familiarities. Those who are familiar with Python, they will find a lot of familiarities. Like you see here, we are basically using numpys. Okay, so np.random.normal. Okay, just define the mean value, standard deviation value, because mean 0 for a normal distribution, mean 0, standard deviation 1, and you just define the overall size, the 3 rows 4 columns. So it will give you the randomized outcome from the normal distribution according to that. So what I am doing, I have just sending you the code in your comment box section. You can check it out, that how to generate the randomized samples. From here also you can see that I am just showing. Once you have run the code, you see again, once you go below, you will be able to see that there are options are coming up, plus code, plus text. So you can click on the plus code button. Okay, you can paste it here, and you will be, then you just click on the run cell button, and you will be able to generate the following outcome. So in this manner, you can generate the outputs. Okay, so now you see that once you are done with that, also you can, what you can do, one important step, that you can also see that, for example, whenever we are telling that in the axis 0 in Python, that means row, axis 1 means column. Okay, so for example, I am just specifying NP array list. Okay, so for example, 2 1 4 3 2 1 3 1 2 3 4, this kind of elements, and I just want to print it in the form of array. So how can you do that? For example, just you see, I am just keeping it in here, clicking on the plus code button. I am just putting it here, and if you run, okay, you will be able to see the following outcome. Okay, so this is how you can incorporate the stuffs, okay, by your own. Because here what we have done here, in earlier cases we have seen, we have generated one of the randomized sample from the normal distribution, where we have the mean 0, standard deviation 1. Now we also have we can generate your desired tensor, okay, by just defining the proper elements in the proper section, proper numerical values. As I told you, that axis 0 means the row, axis 1 means the column. Okay, so you will be able to see this following type of the outcome, which you will be able to generate. Let me paste the code in your comment box section as well. Okay, so you'll be able to generate the outcome in a following manner. Now what we have to do, we will do some simple example related to the operations. Okay, like for example, you may do some arithmetic operations, very simple operations related to the addition, subtraction, multiplication, division, or the exponentiation operation. So simply what I am doing, I am just showing you, pasting the code here, okay, and just showing you that how can you generate the outcome. For example, all the necessary arithmetic operations you may perform there. You see addition outcome, array, doing the simple subtraction, multiplication, division, exponential, all the simple arithmetic operations you will be able to do with the help of the tensors. Okay, so let me paste it in your comment box section, such that all of you can run this portion as well. Okay, so let me go back to the original notebook. Okay, so we are starting from very basic. Okay, gradually we will go to the much deeper. Okay, so now, for example, you want to do the exponential operations. So what you can do, you can simply run the np.exp. Okay, do the exponential operation, and you will be able to generate the outcome. Okay, so here the unary operator will run over it. So np.exp. Okay, if you do and put the variable name, whatever the tensor name you have given there, like x in our case, so we are putting the name there, and we are able to generate the desired outcome. So these are the very basics. Those who are new to this particular field, they will get a lot of confidence by running this kind of the codes. So let us check it out there. Okay, so also I am pasting it here as well, you see. So you see, you will be able to generate all the exponential outcome. So now let us move to the next portion. So what we are doing here, we basically, we have the arrays, we are reshaping it. Okay, and now what we are doing, we are basically creating another array y. Already x has been there, capital X. Now we are creating another array y with the given elements. Now what we'll do some concatenation operation. Okay, so once we are doing the concatenation, so here you see np.concatenation xy, we are providing that x is equals to 0, and again np.concatenate xy axis equals to 1. That means the row wise and the column wise concatenation both will happen. And like I have mentioned, that axis 0 means row, axis 1 means column. So row and column wise concatenation will happen. Okay, so for example, if I run this code here, you will be able to see that these are all runnable code. That's the reason I'm saying that. That is how I'm showing that I am running them in the fresh notebook, such that all of you can get some confidence and get some idea that these all are the runnable code. Very simple amount of the code. You see the both of the arrays now, once the concatenation is happening, you see 0, 1, 2, 3 was the first row of the first array, and the 2, 1, 4, 3 was the first row of the second array. So you see they have been concatenated row wise. Also they have been concatenated in column wise as well. So 4, 5, 6, 7 is the second row, and the 1, 2, 3, 4 is the second row of the second tensor, and the 4, 5, 6, 7 was the second row of the first tensor. So they have been concatenated together. In a similar way, if you see 8, 9, 10, 11 is the third row of the first tensor, and 4, 3, 2, 1 is the second row of the third row of the second tensor. So you see they have been concatenated. So these are kind of simple things you can do. Okay, so no problem at all. You can run these are all runnable code. I am also pasting the code in your comment box. So if you wish, you can try it out. Okay, so you will get the desired outcome. So this is how you can generate this kind of the outcome by running those codes. Okay, so for example, I may want to check that whether x and y both are same or not. I may want to check that. So what I will do, I will simply check x equals y. If their positional values are matching, then it will be printed as true. If their positional values are not matching, then it will print false. So in those areas positional values are not matching, it will give false, and those areas it is matching, it will give it the result true. So in a similar fashion, what I'm doing at this demo window, okay, Colab window, I am pasting the code, you see, and we are checking that whether these two tensors are same or not. So once you run them, you see, for example, the 0 is the first element of the first row, first tensor, and 2 is the first element of the second tensor. Those are not matching. That's the reason false. But the second element in the first row of the first tensor and the second element of the second tensor, you see they are matching. So output will be true. So in this manner, whenever matching, it will be true. Whenever not matching, it will be false. So in this way, you will be compare the elementary input of the two tensors. Okay, so according to the output will be printed. So let me also share it in your comment box. So you just try it out. Okay, you will be able to see the desired outcome. So anyway, so let me go back to the original notebook. Now you can also print the, for example, all the elements. You want to make the elementary summation. Okay, for example, in the for the first tensor, so x dot sum, if you do, you will get the output 66, because it will happen if you see all the elementary entries was there. 0, 1, 2, 3, 4 up to 11 was there. So if you sum up to 0 to 11, it will give you the 66 as an output. So that is the reason you see you are getting the 66 as an output. So this is a very simple kind of things. Okay, so now your concepts related to the tensors will be very, very clear, that that one-dimensional tensor means vector, two-dimensional tensor means matrix, and if you go beyond that, there is no specific naming is there. So we call them as the multidimensional array, and generally multidimensional arrays are referred as the tensors. Okay, so these concepts will be right from the beginning. It should be clear, because you see, otherwise when we will go to the complicated problems, you will not be able to understand it. So that's the reason I am just at the beginning of the session, I'm just giving you a good practice on NumPy kind of thing, so such that all of you will be able to understand when we will solve some of the high level problems. So anyway, so let me go back to the original notebook. So we have implemented the summation part as well. Now let us see some of the interesting stuff. For example, here you see that we are reshaping. Okay, so arrays with 3 elements, arrays with 2 elements, we are reshaping them. For example, 3 row 1 column, or 1 row 2 columns. So if you reshape them and if you print the outcome, you will be able to see the following output. Okay, so let us check out this following example, very simple example. Okay, so if you run the code, okay, here you will be able to see that in first example case, you are generating the 3 rows and 1 columns, the output. So 0, 1, 2. In this way, it will print, because array having 3 lengths with the dimension 3, one D array. Now you see, if we are printing np.arrange 3, so what will happen? 0, 1, 2 will be printed. Now in case of the np.arrange 2, what will be printed? 0, 1. So if you want to arrange them in one row and 2 columns, so how will you be arranged? It will be arranged in the following output, what you are observing here. Okay, so let me paste it in your comment box. Okay, just these are very simple things, but very conceptual thing. Those who are not regular in handling in this kind of arrays or tensors in Pythonic platform, they may feel some discomfortability, or they may feel some discomfort while running the code for solving the higher level problems. So that's the reason we are starting with the very basics. Now you see, for example, we can do the summation as well, simple summation operations. So for example, a plus b, if you do the summations, okay, so simply if you see, what will be the output? 0, 1, 1, 2, 2, 3, simple summation operation, element-wise summation operations will happen. Okay, like you see, I am running the code here also. Now you can see this kind of the output you will be able to generate. So these are very simple steps for you to follow. So just incorporate them, you will be able to see the desired outcome, which you can see this in the screen as well. So I believe that those who are following the steps gradually, they are being comfortable with Google Colab, and as well as this kind of the Pythonic platforms, Pythonic frameworks like MXNet. So now you see, for example, all of you know indexing and slicing. These are the very simple steps. Like you want to select the last element. So what we do, in case of the first element, we start with 0. In case of the last element, we start with -1. Okay. So just for example, I want to print out the x comma x minus 1, the last index, or I want to print the second and third element. So in case of the Python, when you want to print the second and third element, that means index wise it will be 1 and 2 respectively. But you see, in case of the Python, the upper limit will be up to n whenever you want to select n minus 1. So that's the reason 1:3 has been given there. So if you just run it, 1 to 3 will be your overall range of slicing range. So first case, it will print the last element x minus 1, comma x 1 to 3, it will print second and third element. It will not print fourth element, because whenever the upper limit is n, it will always print up to n minus 1. So you see, last element has been printed, okay, due to the -1, and you see the second and third element is also printed as we have indicated in the slicing operation in the index section 1 to 3. Okay. Okay, so in this way you will be able to see the desired outcomes with this kind of the simple Pythonic operations. Now I have defined, for example, this particular simple example, you see, we want to print up to 0 to 2. Okay, now that means first element and second element. Okay, so now you see that what it will do, it will print all those necessary things as we have defined, that our updating value, for example, rest of the things will remain same. In case of the X array, only first and second row will be updated with 12 value. So once you just run this portion, okay, here in the comment box, just you see, if you click on the run cell button, you see first and second row has been updated with all the elements as 12. Okay, so these are the very simple examples. So I'm just showing you, I'm not pasting everything to in your comment box, because just showing you simple of few of the examples, because all of you are gradually understanding what we are doing. So again, if you see the saving memory part as well, now you see one of the interesting thing I just want to show you in the saving memory section. This portion, all of you, I would request to run you. For example, before ID, memory location ID for y was something, whenever we defined now whenever we are writing y equals to y plus x, so memory location will be updated. Now if you, for example, want to match them, id y equals to before, it will give you false. Now, because your memory location has been updated, then like the unlike case, the earlier, I mean the first, when you have generated the y tensor, okay, because now the updated tensor is y equals to y plus x. So you can see the memory location has been updated, and due to that reason, whenever you are comparing them, it will give the output false because their memory location has been updated from the newly generated tensor. Okay, you see the output will be false. Okay, now also let me share the same code in your comment box. You just try it out, because this is something interesting, okay, which you will find. Because why I'm saying that, because in the next example which we are going to show you, that the one common question which comes up in your mind, that whenever you will deal with the higher, when your data size will be very high, you will deal with a lot of other features, then this kind of the upgrading of the memory location will creating the problem. Then what is the trick that your memory location will not be updated, rather in the same location you may save it? Okay, because memory optimization is also an important factor. So how can you do that? So there is a trick. Rather than just writing y equals to y plus x, you can simply write it is y plus equal to x. Like here you can do, we are doing it, one of the steps, or here we can also write it like put some index value. Okay, for example, we want to update x plus y summation in z. Okay, we have initialized it np.zeros like y. Okay, then what we are doing, we are getting the initial address value idz. We have know the initial memory location. Now what we are doing, instead of writing z equals to x plus y, what we are doing, we are putting colon sign. You see the index indicating sign. Okay, and then you are generating the new id. But in that case, you see IDs are matching. So this is the way how you can utilize the old memory locations. So this is one of the tricks which you can use for the in case of deep learning. Okay, this will give you a lot of impact in case of the low processor devices to process your data. So these kind of tricks we should know before going for the before running it on the real data sets. Okay, so these are the tricks you can follow, or in similar kind of tricks is also there in below. Either you can indicate the index sign, or you can indicate it x plus equals to y. So in those cases, you see now if you matching, it will give you true. So let me run it for my case as well. Okay, this is a very simple sort of example which you may explore here. So see, the address locations are matching. So I am also sharing in your comment box section, such that all of you can try it out as well. So it will match. So this kind of tricks we are following here. Okay, so your address location will match. Now you see here also, this trick you may also follow. Rather than indicating the index sign, you simply write x plus equals to y. Like the way we code, writing x equals to x plus y, you can write x plus equals to y. Both meanings, the meaning is same, but in Pythonic platform, if you do this trick, it will save the memory. What is happening? Whatever the memory location was earlier for x, it will overlap that. It will overwrite that. Okay, so your memory locations, you don't have to go for new memory locations. So it will save your memory. So you see the output is true. Okay, so similar kind of things you may do. These are very simple kind of things which you can explore, but the concepts are very, very tricky concepts. Easy, but very tricky. Okay, so people generally overlook this kind of concepts, but these are very, very tricky and quite useful concepts. Okay, so you can try it out by yourself as well. So you will be able to see output will be true. So let me go back to data manipulation portion. So anyway, so this is all about what I want to give you the practice. So these are the nothing new concepts. So you can simply check the type. Okay, so it will give you numpy in the array, or for example, if you are writing b equals to np.array, it will give you mxnet.numpy.nd.array. So these are very simple things. So I am not again repeating it. So a equals to array 3.5. For example, you want to check the floating point output 3.5 because it was already floating point. If you only want to print the integer part, it will give you 3. It will remove the floating point output. So these are quite understandable. So we are not repeating it. So in a summary, we have seen that how the main interface to store and manipulate data for deep learning is basically where you know the tensor is a n-dimensional array. So it will provide you a variety of the functionalities which will include the simple mathematical operation, broadcasting, indexing, slicing, memory operation, conversion to other Python object. So these things are there. So it is a good practice. So we have all incorporated all those things. Now I am moving to next notebook. So do not worry, with these notebooks I will share with the organizers, so they will share with all the participants. So you will get all the necessary theories along with the code as well. Now you see, this is the autograd. Now another important concept in case of the deep neural network, that is the autograd concept. So it will give you the idea of the automatic differentiation. Okay, which you now for doing this thing, I just request to open a very new notebook. Okay, so how will you do the auto differentiation? Just check. Okay, so follow the basic steps which we have done earlier as well. Okay, so we have to import the MXNet. So do the necessary setup. So I am just opening it here, demo. I am keeping it as the demo autograd, demo auto. Please open a new notebook. Okay, just go there. You can see in the file, you will see the new notebook option. Click on that. Put some name like I have given demo autograd. You can give some name there, and you just paste this portion. Okay, just to install all the necessary stuffs. I am just sharing the same code in your comment box section. Just upload all the necessary modules. Okay. So you will be able to see that it is collecting all the necessary things. It is downloading all the necessary ingredients related to the MXNet framework. Okay. So NP and NPX will be there along with the autograd support is the automatic differentiation, which is a very, very important part of the deep learning. Okay. So now what we will do once we are done with it. So the next case is that we will what we will do basically, just a second. So in that case, once we have done all those steps, now we will try to allocate some of the memory for a tensor's gradient by invoking the attached underscore grad. So once you do the x dot attach underscore grad, if you run this, so you are basically allocating the memory location, okay, for this tensor's gradient. So once we have done the memory allocation, then what we will do, basically we will try to calculate the gradient with respect to x. Okay, so we'll be able to access it via grad attribute like x dot grad. And then what we'll do, we will initialize all the values with zeros. So once you are printing with x dot grad, so you will get all the values belonging this tensors will be 0. So we are starting with initialization after the allocating the memory location with x dot attach. Then we are making initialization with all the elementary value of the tensor as 0. Okay. So this portion I am also running it here, the demo autograd section. So you'll be able to see the allocation of the memory for the tensor gradients and their initialization as 0. Okay, so I am sharing something for you in the comment box section as well. So please run it. You will be able to see the desired outcome. Okay, so this portion we are done with it. Now we are again going back to the autograd. Okay, autograd notebook. Now what we'll do in the next step, so we will try to place our code inside the autograd.record to okay, so now what we will be able to see, we will build some computational graph. So with autograd.record, y equals to 2 into np dot, we are doing the dot product yx. So y between x and x, we are creating the dot product. So whatever the dot product out will come up, if you multiply them by 2, you will get 28, because the dot product outcome will be 40. Now we are multiplying with it 2, so it will be 28 as an outcome. So what we are doing, I am just simply pasting it here. Sorry, it is a separate notebook. I am pasting it here. So it will give you the output 28. Okay, see, because we have the elements 0, 1, 2, 3. So if you multiply x into x by doing the dot product, so what will happen? 14 will be the output. Now we are multiplying it by 2. So that's the reason 28 is the output. Okay. So in a similar way, we will go back and see another interesting example. So we are done with it. Now let us move to the next part. Like we already have incorporated, we have seen that x is a vector of length 4. Okay, an inner product of x and x is performed, and it is giving the scalar output which we are assigning into y. Now next, what we'll have to do, we have to do the back propagation. So this back propagation, what will be done, that it will automatically calculate the gradient of y to each component of x. and then it will print the output. So we are now doing the back propagation operation. So this is very, very important operation. So now you see how we are doing it. Y dot backward, x dot grad. So once you do it, 0, 4, 8, 12 will be the output. Once you do the back propagation operation. So same thing, you see, I am running it here. You will be able to see the output. Okay. So you also I am sharing the code in your comment box. Please make sure that you are able to run it. Okay, so in this way you can do this kind of the simple kind of the operations. Okay, now let me move to the next portion. Okay, so now what we'll do, basically you see the gradient function once you do it. So you can what you can do, we can also check out the whether this particular x grad equals to 4x or not, because you see the gradient of the function y equals to 2x transpose x with respect to x should be 4x. Right. So once you know that it will be the 4x if you are taking the gradient, so what we will simply check that whatever the output we got earlier for the x gradient, now whether these are same or not, x dot grad equals to 4x we are comparing. So if the elements will be same, then it will be printed as true, like we have seen for the earlier example during data manipulation. If they are different, it will be false. So if they are same, so it is printing for all the out in cases true. So if this is a very simple example but very important. Okay. So it should match, otherwise there will be some error or mistake. So I am pasting the same code in your comment box. Just check it out. In your case, it will match as well. So let me also show you in our demo code book as well. I am pasting it here and I am trying it out whether the element wise matching is there or not. So you will be able to see that all the elements are matching between x dot grad and 4x, because y equals to 2 into x transpose into x. So once you take the gradient of it, it will be 4x. So that's the reason x dot grad, what we got earlier, okay, by doing the back propagation, it should match with 4x. So if they are matching, then fine, then all the output will be true, true, true. That is what we are getting here as well. Okay. So these are the very simple kind of examples which you may follow. Also, what you can do, you can calculate another function of x as well. So with autograd dot record, y equals to x dot sum. Now what you will do, y dot backward. So once you want to print the x dot grad, so it will be overwritten by the newly calculated gradient. Okay, it is quite obvious. So your output will be all in 1, 1, 1, 1, 1. Okay. So let me show you in the demo code book. Okay. So we are creating the new gradient, newly calculated gradient, which will override the earlier cases. So let me post it in your comment box as well. You can run it there, this portion of the code, okay, and check it out. So this is how you can do this kind of the simple examples. Okay, now backward to non-scalar variables. Okay, so backward to non-scalar variable, this is going to be the very interesting case. Like for example, when we invoke the backward on a vector valued variable like y, which is a function of x, a new scalar variable is also created by summing the elements in y. Okay, so then the gradient of that scalar variable with respect to x is computed. So how can you do that? With autograd dot record, it will be basically y equals to x into x. So y dot backward. Then in the next step, what will do? It will take x dot grad, so which will be equal to basically what? Y equals to some x into x. So it will be basically the array of 0, 2, 4, 6. So this kind of simple thing you can generate here as well. So what I'm doing, I'm clicking on the plus code button and I am putting it here. So once you run this portion, you will be able to generate the following outcome. Okay, 0, 2, 4, 6. Okay, so this kind of simple stuff, you may do it here as well. You can try it out by yourself. I'm pasting it in your comment box section. Please try it out. Okay, so now what we'll do, we will do some detaching of computation. Okay, this is another interesting move, which we'll be able to see. So what we will do during the following backpropagation function, basically the partial derivative of z equals to y into x with respect to x, whenever you are treating u as constant instead of just taking the partial derivative of z equals to x into x into x with respect to x. So that's the reason we are treating y as a constant. Okay, u as a constant. Now you see we are defining with autograd dot record y equals to x into x. Now what we are defining u equals to y into detach. Okay. then what we are doing, z equals to u into x. So we are coming out of that computational graph, okay? And now we are printing it. So z dot backward and x dot grad equals to u. Now you compare between them. X dot, once you compare between x dot grad equals to u, okay? Where after doing the detaching operations, so you see all of them will remain same. So within computational graph and going outside of the computational graph by doing the detaching operations, outputs are remaining same. Okay, so these are very interesting things, but very conceptual thing. If you want to learn and learn the nitty-gritty of the tensor operations in deep learning, so these are very, very important steps. Okay, that whether you are being able to utilize the memory allocations properly manner or not, and what are the alternatives way following computational graph, going outside of the computational graph. Okay, how can you get the optimized outcome? So that is very, very important in those aspects as well. So you can try it out. You will be able to see all the elements are matching, okay, between you and x grad. Now you see this is another interesting operations which we are doing. Y backward, y dot backward. Okay, we are doing the back propagation operation, and then we are also checking that whether x dot grad equals to 2x or not. Which should be 2x, because if you see y equals to x square there, then if you are taking the gradient of it, then what will happen? 2x. So simply x dot grad should match with 2x. So that's the reason within the computation it is matching, and your output, that's the reason after the comparisons for all the 4 elementary entries will be true, okay, because elements are matching. So for example, here I am also running the same thing. If you see, the output will be true if you run them. Okay, so I am showing you that these all are runnable code. I will mail you the notebook. Please practice at your home as well. Also try it out as much as you can execute here as well with me. So it will give a lot of confidences, those who are new. Okay, it will give a lot of confidences. So so for example, we can also try out the next example, like computing the gradient of Python control flow. So like, for example, if you see that one of the benefit which we have observed so far, that automatic differentiation is building the computational graph, okay, which comprises of the loops, functions, or the other arbitrary function calls. Okay, so in the following snippet, if you see that if we have, for example, the overall number of the iterations, if you are executing with the while loop, and if you are doing the evaluation of the if statement, both will depend on the value of the input A. This is quite obvious. So like I am creating a particular function, I'm defining a function of A. Then what are the conditions I am adding? B equals to a square. Now you see now you see that while np dot linear, we are doing this doing the normalizations of b, which is less than thousands. Now you see b equals to b into 2. Now if b dot sum greater than 0, c equals to b, or else it will print that c equals to 100 into b and return c. So this is the overall outcome of the function definitions in this particular Python control flow section. Okay, so now you see, if you are doing like that, so we are using a lot of if loops and while loop, but you see that all of this looping, whatever we are doing, it is mainly depending upon A, which we have defined at the beginning. Now you see that if you are running these portions, so these portions will run without any error. Okay, you will be able to see the blue tick, green tick there. Once you run this portion, then what we'll do the gradient computation. So first we have defined the function. Okay, so once you have defined the function, you see the code is running without any error. The green tick is there. Now once you do the gradient operation over it, you will be able to see the outcome from it. So what I am doing, I am just sending you this particular portion of the code. Now you see what I am doing now. We are just simply do the gradient operation over it. Okay, so let us compute the gradient. So how will you compute the gradient? Simply, first of all, np.normal.random, you just define it, then do the attach. You know the attach, we are starting with the initialization of the gradient operation. Then with autograd.record, okay, just keep d equals to function of A, and you just calculate d.backward. Okay, so just take this portion, okay, and I'm just putting it here. Okay, so there will execute without error free. You see The green tick is there. I'm also putting it here as well for you to run the code. Now, once we have completed these steps, now what will be our next step? Just to check that we have analyzed the f function in how the function definitions above, and now what will be done, that it is basically the piecewise linear in its input over its input, whatever we have given there, a. So now, in other words, you can see that for any a, there should be exist some of the constant scalar k. So for forming function of a equals to k into a, okay, where the k value depends upon the input of a. Now we have to check that consequently that d by a allow us to verify that the gradient is correct or not. So if I do a dot grad d by a, if our gradient calculation is correct, it will print true. If our gradient calculation so far is wrong, it will print false. So let us check that whether we have correctly calculated this gradient part or not. Okay. So simply what we are doing, we are just putting it here, and we will check what will be the output, true or false, in case of the gradient calculations. Okay. So your output is true. So you see the gradient calculation is correct. So in your case, you can also check it out there. I'm posting it in the comment box. Just do the execution of the operation d by a and check that whether your gradient outcome is true or false. If it is correct, output will be true. If it is wrong, it will be printed as false. So in our case, output is true. That means it has been computed correctly. So in a nutshell, what we can say that the deep learning frameworks basically can automate the calculations of the derivative. To use it, what we'll do, we first attach the gradients to those variables with respect to which we desire to execute the partial differentiation operation, partial derivative. Then what we are doing, we then record the computation of our target value and executes its function for the back propagation and access the resulting gradient. Okay, the way we got it. So this portion we have done. First of all, we have learned about the data manipulation. Then we have checked out for the auto gradient. Okay, now we will execute a very simple portion which is related to the dropout operations in deep learning, because all of you know that in dropout is done to remove the overfitting operation. In case of the shallow network, okay, in case of, for example, machine learning, we have seen underfitting is a very common phenomenon. Okay, underfitting means high bias will be there. Now you see in the deep learning, we see the overfitting is a common phenomenon. For any dense network, deep learning will be a very common phenomenon as overfitting. And this is basically high due to the reason of the high variances. And you can remove them by using overfit, this kind of the dropout operations. So common practice in case of, from our basic knowledge of the classical machine learning algorithms, that you can do the normalization. So in probabilistic, you can do the regularization, okay, to remove the overfitting. Now you see in probabilistic terms, if you see that we could justify this technique by arguing that we have assumed that a prior belief that this kind of the weight takes a value from the Gaussian distribution. So that's, you can see that we, whatever the randomization operation we are doing, have to create the Gaussian distribution where mean value 0, standard deviation 1, and we are defining the number of rows and columns according to the tensors who are being printed. So we always assume that the weight takes values from the Gaussian distribution where mean value is 0 and standard deviation 1. So more intuitively, we might argue that we are encouraging a model to spread out its weight among many features rather than just depending on such small number of the potential spurious associations. So in a nutshell, just remember that regularization is one of the important factors in removing the overfitting, removing the phenomena like the overfitting. And also dropout plays a very, very significant role there as well. Now we'll see some of the simple examples. Theoretical portions are there in the notebook, so you may go through that. I am not going into much theoretical details because time is, we have some limited time. So we will mainly focus on execution of the coding part. So now you see that. So first of all, you see, just look at this diagram before going to the coding portion. In an overview, in a pictorial overview, you'll be able to understand in what we are doing in the dropout layer cases. So you see, basically x1, x2, x3, x4, x5, we have started as the input layer. O1, O2, A3 is the output. So input and output, we are not doing anything. Just dropout operation is always executed during training of the algorithm. Remember, because you see overfitting phenomena happens that when you are getting very good output in your during the training of your algorithm, but during the validation of your algorithm, we are getting the poor output. Okay, so that is a problem related to generally the overfitting phenomena. Now, during the dropout, we don't use dropout during testing. We only use the dropout during the training of the algorithm, and mainly we will execute by reducing some of the hidden layers. Okay, we are dropping out some of the hidden layers. So you see here in the first example, in the leftmost example, H1, H2, H3, H4, H4, 5, there are the 5 hidden layers. After doing the dropout, we are basically chopping out the H2 and H5 from here. And we are executing with H1, H3, and H4. So now the model becomes the little bit of simpler than the earlier complex deep learning model. Okay. Now the newly after doing the dropout operation, the deep learning architectures are looking a little bit of simpler than the earlier, because making the model too much complex, what will happen? Your error will be affected. Your model performance will be affected, and that's the reason in most of the cases it is doing very well in case of the training data set, but miserably failing with the validation cases. So dropping out does that kind of the job. So now let us do the very simple example by exploring it. Okay, over this kind of the example. So let me open a new notebook to give you the demo of this portion. Okay, so what I am doing, I am just giving the name of this new notebook as the demo dropout. Okay, so I am requesting all of you to open a new notebook, put some name like demo dropout. Okay, demo dropout. Okay, so the new notebook name is demo dropout. Now we are doing what we are doing. We will do some very simple examples, explore simple examples over it. So basically, first run the first portion of the code where the necessary modules will be downloaded, and all the conditions of the dropout which you want to put, you will put by defining this the dropout layer function. Okay, we have just defined the dropout layer function, and we have given some corresponding conditions that how you want to execute the dropout operation during training of your algorithm. So you just execute this particular state, you will be able to see all the necessary modules are being installed, and your basic dropout conditions have been highlighted there with the help of the function named dropout_layer. So you can see that the following code is running successfully. Okay, so once we have done this portion, what we'll do, we'll move to the next portion of the operation. So basically we can test out the dropout layer function on a few examples as well. So in the following lines of code, what we are doing, we are testing the efficacy of this dropout function, basically dropout_layer function, which we have defined in the beginning of our code. So we can pass our input x through the dropout operation, which probabilities will be 0, 0.5, 1 respectively. Okay, so just let us check it out for the few cases. Okay, so remember the probabilities values are 0. That's the reason print dropout layer x, 0, 0.5. Okay, dropout_layer x, 0.5, and again print dropout_layer x, 1. Okay, so we are trying it out for 0, 0.5, and 1 respectively, and we will be able to see the following kind of outcome. So in our case, you see it has been run successfully. You see green tick has been given there. Also the runtime has been given there in second, 37 seconds it took to execute all the necessary operations. Now you see you can click on the plus code button. You just paste the coding portion here because you want to test the performance of the dropout_layer function. So the following kind of outcome you will get of the dropout layer for 0 probability, 0.5, and 1. So following output will come up. Okay, so now what we will do, you see that first case in X, when we defined np.arrange will create 0 to 15, okay, values, and we have given it in a shape .reshape, okay, 2, 8. That means 2 rows, 8 columns. So in first row it will be 0 to 7, okay, and in second row it is 8, 9, 10 up to 15. And once you do the dropout with 0.5 probability, so you see it is dropping out. It is printing 1, drop 1, printing 2, drop 3, printing 4, drop 5. So in it, because probability is half, 0.5. When the probability is 1, you see all the outcomes are 0. So this is how the things are being operated. Okay, so you try out yourself. I am pasting in the code in your comment box so that you will be able to run this portion of the code. So you see the beauty of this portion of the operations. So it's all about, I mean, how you are defining the dropout probability. to execute certain operations. Okay. Now what we are doing, we are defining the model parameters as well. So again, we are we'll work with the fashion immunized data set. Okay, we'll define MLP with 2 hidden layers containing 256 unit each. So once you run it, so first of all, we'll check that will define all the details of the immunized data set to execute them, input layer, number of output layer, hidden layer. Okay, all those things we will define first. Then we'll do the operations related to the dropout. So first of all, let us define those things. So if your definition is correct, the code will execute without any error. So in my case, I'm showing you that it will not be giving an error. Okay. So you see, it is running successfully. Now I am pasting it in your comment box so that you will be able to run this portion successfully. Okay. So once we have done this portion, okay, so now what we'll do, we'll go back and we will define the model with the dropout probabilities. Okay, so in dropout 1, we are giving the probability 0.2, dropout 2, we are giving the probability 0.5. So now we are defining the net with proper reshaping, okay, and introducing the ReLU activation function. Like I told you, in deep learning, ReLU plays a very, very significant role. So all those operations, okay, NP dot product will be there between X and weight, okay, which we are giving W1, then we will add bias D1, okay, use the dropout only when the training of the model is being executed. So if autograd dot is underscore training is happening, then we are adding the dropout. You see, add a dropout layer with first fully connected layer. So H1, okay, dropout underscore layer, H1 dropout 1, the value is 0.2. Then H2, we are again defining NPX ReLU. We are doing the NP dot operations between, it is the input and the weight, okay, plus B1, we are doing it for the first fully connected layer, and for the second fully connected layer, hidden layer into weight, the dot product is happening. We are adding the bias B2. Then if autograd is training, now once the training is happening, what we'll do, we'll add up the dropout layer. So dropout layer after the second fully connected layer. So this is H2 equals to dropout underscore layer H2 comma dropout 2. Then return NP dot, okay, dot product between H2 and W3, and B3 is the bias. Okay, these are the simple standard mathematical structure of the any neural network model. So we may remember that dropout 1, which has been executed with value 0.2, and dropout 2, 0.5. So once this portion has been done with successfully, you see there will be no error. Okay, so let us check out here. I am pasting it here. You see it will be executed successfully without any error. So I am also pasting it in your comment box section as well. Okay, you can see you will be able to run it successfully, this portion as well. So we are done with defining the dropout 1 and dropout 2 layer. Okay, so now what we'll do, we will simply go to the next portion, training and testing portion. So in training and testing portion, what we'll do, this is very similar to the training and testing of MLP describing before. So what we will do, we will simply run this code here. So what I am doing, I am pasting the code here. Okay, you will be able to see that how you will get the optimized outcome. Okay, so also let me send you the code in your comment box, as that meanwhile you can also run this portion, okay, to check out the optimized outcome. So once you are able to run it successfully, you see, you will be able to see that, you see, when the number of epochs are increases, you see what are the number of epochs we have defined it here, 10. So x-axis is the number of epoch, 10. Okay, so you see, and y-axis is giving you the percentage of the accuracy. Now you see, with the number of the epochs, when you are increasing the training loss is decreasing. That is the main motto, that training loss should be decreased. In the blue line, if you see, the training loss is decreasing, and this particular green line, green dotted line, or this pink dotted line, which are showing the test accuracy and the training accuracy respectively. So it is doing pretty well. Okay, so we are getting almost nearby 95% accuracy. Okay, so this is how we can make a conclusion that our model is doing pretty well. Now what we'll do, with a high level API, we also need to add dropout layers after each fully connected layer by passing it on the dropout probability, okay, as it only doing the argument for its constructor. Okay, so basically what you will do, not in the training mode, but dropout layer will simply pass the data through testing as well. So for example, if you are defining net equals to nn dot sequential and we are adding some dense layer, okay, where you are basically giving the activation function value at a dropout layer after the first fully connected layer like we have done it earlier. So nn dot dropout 1, nn dot dense. So 256 activation value, because in earlier case what we have done this operation for the fully connected layer. Now we are doing it for the dense layer. Now nn dot dropout, okay, to nn dot dense, then initialize them, okay, with the sigma value 0.01. Okay, so what I'm doing, I'm sending this portion of the code to you in your comment box, so you'll be able to run it easily. So this is how you can execute these portions of the code quite easily. Okay, so let me go back to my notebook. Okay, so just a second. Now what we can do, we can simply once you run it successfully, we can also simply train this portion. So we will define the trainer, gluon.trainer, net.collect param. Okay, now the stochastic gradient is in SGD has been defined, learning rate error is given there. Okay, and then you just run this following code. Okay, by taking net, training iteration, testing iteration, loss, number of epochs, and trainer. So you'll be able to see this kind of the following outcome will be generated. Okay, so let me check that whether in my cases I'll be able to generate the plot. Okay, you see the graph has been generated successfully. Now let me run the next portion. Okay, so we have defined that how we are adding up the first the dropout layer after the first fully connected layer and second fully connected layer. Okay, well, like we have done it earlier as well. Now what we will do, we will basically, just a second. Oh, we are doing it for the dropout layer, right? So it is this particular notebook. Okay, now what we'll do, we will simply use it to the number of the iterations and all those things to give you the performance generated curve. Okay, so let me send it here and also in your comment box. So it will, meanwhile it will execute the overall code. Let me share it in your comment box as well. So you'll be able to see that during the fully connected layer and dense layer, in both the cases, we are observing that with the number of the iterations, okay, you are getting the optimized training accuracy. So it is executing here. So I am showing you from my original notebook. So that's the reason I'm not tampering with the original notebook, which I have prepared to share with all of you. I am doing it in a separate code book. Okay. So you see the blue curve, training loss with the number of the epochs, it is defined as 10. So it is training loss is reducing with the number of the epochs as desired. And you see the training accuracy is also increasing, which is a pink dotted line you can see. And also you can see the test accuracy is also maintaining a standard position, which is a green dotted line, almost over 80% in most of the cases, to 80 to 90%. Okay, so this is how you can see by doing this kind of the dropout layer, implementing dropout layer, you can check out the reduction in the optimization. Okay, in overall, reduction in the overfitting of the deep learning model and incorporate the optimization. So you see that beyond the controlling the number of the dimensions and the size of the weight factors, dropout is another tool to avoid the overfitting. Okay, so they are often used jointly. Okay, and dropout replaces the activation age with a random variable and with the expectation value of age, and dropout is used during training of the algorithm. Okay, so we have seen that how the dropout can be used to reduce the overfitting and optimize your system performances. So now, once we are done with it, we'll move to the next portion. That is for example, the simple concepts related to the multi-layer perceptron in deep learning. So what does it mean by multi-layer perceptron? So don't worry, every theoretical details are given there. So you see here also in the summary section, do not forget to go to the summary section. Even you see here also adding added different important things which have been like the multi-layer perceptron. What it will do, it will add multiple fully connected hidden layers between output and input layers and transforms the output length of the header layer as an activation function. And you see, commonly used activation function already we know, ReLU for deep learning, sigmoid and tan hyperbolic for machine learning. So now you see, once we are proceeding with it, so as the times are very short, I'm just moving towards the coding portion. So we have seen what is multi-layer perceptron, and you see once you come up, the activation function has been defined there, all the details have been given there, theoretical details are there, so you can check it out there. So now please open a new notebook and we will do all the necessary setups like installing installing D2L, which will give you all the deep learning activity related stuffs which are version independent. Okay. Version installation independent, and then what we'll do, autograd, NP and NP extensions, which will do all the necessary deep learning framework related operations. Okay, so now what we are doing, I am just clicking here. Okay, you see this code also has been executed successfully and following outcome has been generated. So now I believe that all of you are getting the confidence that whatever the codes I am sharing, all these codes are the runnable codes. Okay, so all of you can easily run them at your convenient time in your home as well. So this particular new notebook, give them as a demo MLP, multi-layer perceptrons. Okay, so just put here demo MLP. Okay, multi-layer perceptron MLP. Okay, now I am incorporating all the necessary stuffs related to the installation like NXNet or the installation like the D2L. Okay, we are doing all the installations. Also, let me send those things to you as well in the comment box. So anybody from the organization team is there? How much time left? Can anybody guide? Okay, so it's now 1:35, so we can carry on up to 2, right? So we have time. Okay, anyway. So this is how we are doing the necessary installations. Okay, so once we are done with it, then what we'll do, we will simply incorporate the next portion, provide to the next portion. Now we all know ReLU, like I told you, the ReLU have a ramp-like structure. Okay, so basically for the negative values of the negative, in case of the x, in the negative values, it will not exist. Okay, in case of the x greater than equals to 0, it will give you the straight line curve. Okay, straight line passing through origin, which is a ramp-like function. Okay, so that's the reason ReLU x max of x comma 0. Okay, for negative value it will be 0, for positive value it will be x. So what we will do, we will plot the ReLU function. So I am showing you that how to plot it. So all the necessary installation has been done. Now we are generating the ReLU function. Okay, like I told you during our discussions that I will show you that how to plot ReLU function. So this is how you can generate the ReLU function, where we have defined the necessary range minus 0.8 to plus 0.8. Oh, sorry, minus 8 to plus 8, and the interval is 0.1. Okay, so we have defined the upper limit and lower limit, and we have given the intervals where we will take the discrete points. So now you see we are generating this kind of the value. You see it is extending from minus 0.8 to plus 0.8, minus 8 to plus 8. Okay, and this is the ReLU function curve. Okay, you see the ramp-like structure you can observe in case of the ReLU. For the negative values of x, it is not existing. It is only existing for the positive values of x. Okay, so this kind of the curve we will be able to generate for your case as well. Okay, so let me send it to your comment box section as well. So these are the very simple operations which you can do for your case as well. So we have successfully generated the ReLU function. Now we will move to the next portion of our discussion. Okay, so once we are done with the ReLU, now we will see that when the input is negative, the derivative of the ReLU function is 0. You see all the theoretical details are given there. So when the input is positive, the derivative of the ReLU function will be 1. So note that ReLU function is not differentiable when input takes value precisely equal to 0. Okay, so make sure that this is the one of the problem related to, we call it as vanishing moment problem. That's the reason from the ReLU we go to leaky ReLU. Okay, where we have some value, very small value in those cases from 0.01. Okay, because you see input that it is not will be differentiable when the input takes the value precisely equal to 0. So that's the reason we go for the leaky ReLU, parametric ReLU. Okay, ReLU having the problem with the vanishing moment. Okay, so in these cases we default to the left hand side derivative and say that the derivative is 0 when the input is 0, and we can get away with this because the input may never be equal to actually be 0. So there is an old adage that if the boundary conditions matter, we are probably doing the real mathematics, not engineering actually. So that conventional wisdom may be applied here. So we plot the derivative of ReLU plotted below. So what we are doing, I am showing you that how the ramp function, if we do the differentiation of the ramp function, how it will look like. So you see the ReLU structure, if you do the differentiation, it will be basically a step-like function. Okay, so if you do the differentiation of the ramp function, what you get? You basically get the step function. This is a very common question in the GATE exam as well. For the EC students, that we see that ramp function is given there. If you do the derivative, whatever will be the outcome, it will be the step function. So same thing, because ReLU is a ramp-like structure. So once we are implementing the differentiation, so y dot backward, okay, then you just do the difference once the back propagation operation is done. That means we have done the differentiation operation, and you see you will be able to generate the following outcome. Okay. So these all are runnable codes. If you run them, you see this type of step-like function you are being able to generate. Okay, so I am also pasting the same code in your comment box section. Okay, so from our basic knowledge of signal processing, we all know that this is going to happen, that if you are taking the derivative of ReLU, you will get this step function. Okay, if you are making the integration of step function, you will get the ramp-like function as an outcome. So ramp-like function means it will have the structure like ReLU. Okay, so let us go back to our discussion. So this kind of output you will be able to generate. Okay. So also you see that I have already highlighted here in the theoretical section that about the parametric ReLU, which will remove the problem related to the vanishing gradient problem. The paper of the parameterized ReLU has been launched in 2015 by Jan and his research group. So parametric ReLU P ReLU X, max of 0, x, alpha minimum of 0, x. Okay. So this is the definition. Now also all of you know that sigmoid function, which was very popular as an activation function for machine learning, it has the structure like the logistic regression equation. So sigmoid of x equals to 1 divided by 1 plus exponential of minus x. So let us see. So this particular curve of ReLU, now it is quite clear that it is performance or scalable. If you see this curve, which we generated here also, okay, you see from 0 onwards, it is continuously scalable. That means that's the reason with the help of the deep learning, even you can generate the accuracy for even for 100% as well. It is possible to achieve the highest accuracy. But using the activation functions like the sigmoid, the performance curve will saturate somewhat. So if you see the curve of the sigmoid function, which we are going to generate here, so you see after certain scalability, gradually it is saturating. So after a certain extent, it will be saturated. For example, it is after achieving 85% or 90% or 95%, performance will saturate somewhere with the machine learning. But deep learning gives you the continuous scalability. So for example, I am implementing the same portion of the code in my notebook, you see. So once you run it, you will be able to generate the curve of the sigmoid function. So this type of simple operations, you can do it for yourself as well, like I am doing it here. Okay, I'm also sending it in the comment box section. Please check it out. So you can successfully generate the curve for the sigmoid function. In a similar fashion, if we want to do the derivative of the sigmoid function, so what will be the happen? That sigmoid of x 1 into 1 minus sigmoid of x, that will be the curve. So it will give, you will basically get a Gaussian-like structure. Okay. So derivative of the sigmoid function will give you a Gauss-like structure. Okay, so let us execute in the notebook as well. So you see, so you are now being able to generate the Gauss-like structure. Okay, by implementing this simple portion of the code. So also sending you in your comment box. So please try it out by yourself. So you'll be able to see the following kind of outcome, okay, which I showed you in the notebook. Okay, so in a similar fashion, we can move to the next part as well. So once we have generated this curve, also tan hyperbolic is another popular function related to the activation function in machine learning. So in case of tan hyperbolic, the range is -1 to +1. Okay, like unlike in case of the sigmoid function, what we are taking, basically we are considering it from 0. Okay, 0 to 1 in the y-axis range. But in case of the tan hyperbolic, the y-axis range is -1 to +1. So the equation is tan hyperbolic of x is 1 minus exponential of -2x divided by 1 plus exponential of -2x. Okay. So if we run this particular code, okay, so let us generate the tan hyperbolic curve as well. So in both the cases, you will see the performance will saturate somewhere after certain scalability. Okay, curve will start increasing and then the performance will be saturated. Sigmoid and tan hyperbolic. That's the reason I am saying that it's all about the mimicking human activity. Our performance is also saturated somewhere. So the philosophy of relating the sigmoid and tan hyperbolic is the mimicking human activity, but the ReLU having the philosophy behind the superhuman activity. It is a ramp-like curve, continuous scalability can be possible. So if you see this is the ReLU, this is the tan hyperbolic curve we are generating. Now I am also posting it in your comment box section. All of you will be able to generate this portion of the code quite easily in your notebook as well. So this is how we have incorporated this portion as well. Now we want to generate the derivative. So derivative of tan hyperbolic, what will happen? 1 minus tan hyperbolic square x. So y dot backward del. Now if you plot these things, so you will see again the Gaussian type of curve will be able to generate. So let me show you that how I am doing it in my case as well. So let us execute it here. See again, you see the once you do the derivative of the sigmoid or tan hyperbolic, you will see this kind of the Gaussian distribution kind of curve you will be able to generate. Okay, let me share it in your comment box as well. So these are the interesting things which you may explore out by yourself, and you can check out that how these interesting deep learning phenomena are happening. So now if we see in overall execution of the code, we have seen so far that MLPs, that means multi-layer perceptrons, are adding one or multiple fully connected hidden layer, which we have discussed earlier during the beginning of our talk, when the output and input layers and transform the output of the hidden layer via an activation function. We have talked about different activation function, tan hyperbolic, sigmoid, as well as the ReLU. We have run the codes, we have generated the plots, and commonly used activation include the ReLU function, the sigmoid function, and tan hyperbolic function. So these are the very important things which we have explored. So if there is time is permitting, then I will move to some of the practical demonstration, okay, on the Kaggle dataset, which is a house pricing dataset. Okay, will the time permit me to do that? All of you know that the Kaggle is a very elegant platform of doing the data science competition. So from the Kaggle, all the theoretical details are given there, how to download the data sets, what are the resources, what are the important papers related to, everything is there. So it will be all about the predicting the house price on Kaggle. So is there anyone from the organizers? Can I proceed with it, or should I show it in my next lecture on 31st? Okay, so till 2 p.m. let us continue. I believe that within 2 p.m. we'll be able to complete that part as well, because it is 1:47. So I think we can carry on for 10 minutes more at least. Okay, so some text, I can see some text is there. Okay. So now let us check out this portion. First of all, what we'll do the common practice. We will install all the necessary things which will be required to process the data. So in case we are starting with the first case. So also I will also open a please new notebook. So what we will do, we will do the notebook name now, demo Kaggle. Okay, let us give the notebook name as demo Kaggle. Okay, so we can carry out simple operations there. So give the notebook name demo Kaggle. Okay, so we are taking the data set from predictions of the house pricing from the Kaggle, and we will incorporate deep learning on them. So please follow these steps like I have done it here. I am also posting it here as well for you. Okay, make sure that you are incorporating them. So if you have too many open notebooks, you may close some of them. Okay, you may terminate some of them, and then you may run the code. Okay. So then you may run your code as well. So have I pasted in your comment box? Let me check. Okay, already sent. So let me go back to my original portal. Okay, so now I have come back here. Now what we'll do once we have done this portion, so now the following download function will basically what it will do, it will download the data set, okay, which returns the name of the downloaded file, and if a file corresponds to this particular data set that already existing in the cache directory, so what will happen that SHA1 will matches that one stored in data hub, and our code will be used to cache file to avoid the clogging of our internet with the redundant downloads. So in this manner, you will be able to download it. So let me send you this portion, okay, where you will be able to download the code. So in my case also, let me run it in the new notebook, demo notebook, and also send me to you guys as well, such that all of you will be able to run it successfully. So this download function will help you to downloading of the coding materials. So data set material. Okay. So once we are done with this portion, now what we'll do, we will also implement two additional utility functions. One to download and extract the zip or the tar files, and the other to download all the data sets. Okay. So used in this particular notebook. So let us give you the code portion as well. In my case, it has also run successfully. Let me run this portion as well. Extraction of the zip file or the tar file, which we are going to use it. Also sending the same in your comment box section as well. Okay. So once this download portion is done, then what will be our next step? So basically, we will now proceed towards the next portion. Okay, so there are details are given there. What is Kaggle, how we can take the participation Kaggle competition. So now, if you're, for example, if the pandas are uninstalled, then you have to install the pandas as well. In my case, you see, we are using Colab, so pandas are already there. We will only install the MXNet and D2L to support the deep learning operations, like we have done earlier cases as well. So those things we are just doing. So let me do it for my demo notebook. Okay, so all those things are running successfully. In your case, it will also run successfully. Just reproduce the results. I have already pasted in your comment box. Okay, so once you are done with these steps, okay, now what we'll do, we will basically move to the next portion. Okay, where for our conveniences, what we'll do, we can download and cache the Kaggle housing dataset using the script we defined above. So the things we are doing, because house pricing dataset we are going to use it, so we have to incorporate those things as well. So it is executing all the installation operations. So meanwhile, let me paste the code in your comment box. Okay, so I have sent the code in your comment box section. Now let me move to this part. Already it has executed it successfully. So let me click on the plus code button and run this portion of the code here as well. So you will be able to see that the following house training dataset and testing datasets, it is downloading. Now what it will do, we can use the pandas to load to CSV files which are containing the training data and test data successfully, because already have download. Now what we want to do, we want to upload basically this CSV file. So pandas will be required. We all know from our basic knowledge of Python that pandas does all the data manipulation related task. So you see, you can do it with the help of the pandas as well to upload the CSV files. So we have done it. I have also pasted the code in your comment box. Please check it. Now, once we have done this portion, then what we'll do, we will simply go to the next part. Okay. So now, basically, this training data set, remember, this is comprises of the 1460 examples with 80 features, one labeling of the data set, and the test data containing 1459 examples with 80 features. So simply just print the train data set and testing data set shape. If you want to print them, you will get the proper outcome. Like in my case, I am doing it here as well. So this will give you the proper outcome. So also let me send you in the comment box. So you can see, you will get the desired output, which you want to check out for the dimensions of the data sets. Okay. So once these portions have been incorporated successfully, then what we'll do, we will basically move to the next part. Okay. You can also check out, for example, let us look at the first 4 and the last 2 features as well. Okay, of the sell price. So if you want to do that, so it will let us check out how the data set looks like. So this is a very common practice. There should be curiosity that how your data sets looks like. So you can try it out here. Okay, and you will be able to see that how your data set looks like. So this is the basic, the IDs. Okay, cell type, cell condition, cell prices, all those columns are there. Okay, so you can try it out yourself as well. I am pasting the code in your comment box. Please try it out by yourself as well. So this is how you can try out different interesting things. Okay, you can also see each example having the first feature like ID that helps to the model to identify, okay, about the each training examples, while this is convenient that it does not carry any information for the prediction purpose. Otherwise, it will add up the unnecessary biasness in the system. So hence, we remove it. If something is there, we'll remove it from the data set before we are feeding the data into the model. So now all features we have connected. pd.concat function is there. Okay, so according to, we have segregated the test data allocation or training data allocations. Okay, and now I will run it for my case as well. Also sending all this particular portion of the code in your comment box as well. Please incorporate it. Now we'll move to the next portion or discussion. So once we have done this portion successfully, now data pre-processing is required. Okay, so as stated above, now you know that we will do the normalization. So data minus mean divided by standard deviation is a common practice. Okay, to standardize your data during the pre-processing steps, we have done that. Now what we'll do, if your test data are inaccessible, mean and standard deviation could be calculated from the training data as well. So that is what we are incorporating here. You can see lambda x minus mean divided by standard deviation. What we have done, x dot standard deviation. So this is how we have done the normalization. Then after standardizing the data, which that means all means will vanish, and we can set the missing value to zeros. Okay, now we have done the missing value zeros with the fill.na equals to 0 extensions here. Okay, and storing the result under all features, numeric underscore features. So you can try out yourself. Okay, let me also paste in my demo code window. So I am running it here, you see, and also I am sending you in your comment box section. So please run this portion. Okay, so where we are doing the standardization of the data set, we are removing all the missing values. Okay, now let me go back to my original notebook. So once we have done this portion successfully, now what we'll deal, we'll see that now our target is to deal with all the discrete values. Okay, so this includes the features such as the MS joining. We can replace them with the one-hot encoding in the same way that we previously transformed the multiclass into vectors as well. For instance, MS joining assumes that the values like the RL or the RM, and dropping the MS joining features, 2 features which are related to the MS joining RL and MS joining RM, which are creating with the values like 0, 1, okay, which we are contributing in the contributing in the prediction level. So we are dropping them, and according to one head coding, if the original value of MS joining is RL and the MS joining underscore RL is basically 1, and MS joining RM is 0. So pandas package does the actual automatically for us. So pandas package is basically playing a very, very vital role in our execution portion of this codes. Okay, so let me send you the next portion of the code. So I think that somehow my system has hanged actually. Okay, so let me stop screen sharing just a second. It has hanged. So give me some time. Actually, the main machine is not running. So we will put the next portion of the code. Okay, so such that all of you will be able to run it successfully. So Actually, too many Kaggle, too many collab sessions are running. So I am gradually stopping one by one, which are not important as of now. Already we have completed those steps. So I am just stopping them from the execution. So it will give us the speed of the executing the current code in the notebook present there. So we have stopped those things. Just a second. The page has become actually unresponsive. That's the reason it is happening. Okay, so let me reopen it. So let me close all the other notebook windows. So now it will be easier for us to incorporate. Okay, so now it has been able to, I have been able to open it. Okay, so once we have done it, so with the help of the pandas package, you will be able to see the all features safe, which are now after dealing with the missing values and standardization, you will be able to see. So I'm sending this portion of the code to your comment box. Just try it out here. Also, let me run it in my comment box.
Sir, this is Soman here. Soman here, sir.
Yes.
Please conclude this session.
Okay, almost we are done.
Actually,
Actually, almost we are done. We are
actually
done.
we have to give the participants break. Okay.
Okay, sure. Just a second. That's the reason I was asking that is there anyone from the organizers? So it will help me to wrap it up because I was asking about the time. So just give me 2 minutes. Just let me just show them that how to run those portions. So I am not anymore posting in your comment box. So all the notebooks will be sent to you. So just I am showing you that how you can run this Kaggle data set. Okay, for the house value predicting purpose. So this portion has also run successfully, you can see. So now we will go for the training portion as well. So in the training portion, you can see that we will basically see the linear model also can serve the purpose for the baseline, which will give you some intuition that this some kind of the simple model which will help you in case of the best reported model, okay, and give you the optimized outcome. So we are defining the loss function here, and you see we are running it here as well successfully. So you will be able to see the following output after doing the training portion. Now what we are doing here, we are basically will calculate with the measurement if there is some discrepancies. So RMSE value will calculate, root mean square error value will now calculate here. So this portion of the code will calculate the root mean square value. Okay. So let me run this portion. Okay, so it has also run successfully. Now what we'll do, we'll define this particular train function where all the details, training features, training levels will be able to execute. So you can try out your home as well, this portion of the coding. I'm just showing you that how we are following the steps one by one with defining the batch size, learning rates and all those things. So once we are done, we can follow the cross-validation, k-fold cross-validation step here. So simply the next steps will be the k-fold cross-validation here. You can simply run this portion. You see these portions are also running successfully. So all of you can get now are getting the confidence that all the coding portions can be run through successfully. So this is the part where you can check out the training and the verification error average as per the output we can see. So then finally the model selection. This is we are gradually going towards the closing session. Okay, so once you just complete this portion, so after you run it, okay, so you'll be able to generate the following outcome. The output curve will look like this. Okay, so once the number of the epochs will increase, here we have taken the epochs 100, so error will decrease. Okay, training error will gradually decrease. Now you can submit your predictions report to Kaggle as well. So I am not showing this portion. Okay, so this is the main portion which you have been able to see the outcome. Now, if you want to see the predictions report to Kaggle, so next steps you may follow. So all those things we have covered right from the beginning. Data manipulation, how can you do it? Then we have done a lot of operations related to how to do the dealing with the dropout operations over the data sets. We have also learned about the multi-layer perceptrons. We also learned about the other nitty-gritty of the deep learning, how to run the original data sets, like we have dealt with the Kaggle data set, which is the house pricing predictions. So here you can see the output has been able to generate successfully. The following graph will be generated once you are able to run the output. Okay, so you see that the error, training and validation error will decrease once your gradually will increase the number of epochs. So that's all about today's session. So I believe that within time somehow I have been able to wrap it up. So I believe if then the page don't become the unresponsive, then I would have been able to incorporate this much earlier, complete this session much earlier. So anyway, please feel free to share your feedbacks of the session. I believe that it will be helpful for you. Those who are expert, they already know those things. Those who are new to this particular field, I believe it will help all of you to execute the code successfully. I will send today's notebook, what we have incorporated here, to the organizers. So they will definitely going to share with all of you. So kindly share the feedback of the session by commenting on the comment box. It will be a great help for me as well. So thank you very much for your patience joining the session. To all the respected participants, I am very much thankful for your kind patience. So thank you. Thanks to organizers as well for inviting me here. Thanks a lot. Thank you very much.
Okay, sir, that was a very nice and informative session, particularly coding session in a hands-on experience. So now this is a time for the participants for a question answer. If you have any queries, you can ask to sir. Already sir has given all the data. Of course, we will share it. That is in the chat box. We will share to the participants, sir.
I will also separately email the notebooks to you as well, to the organizers.
Okay.
So you can share with them.
You.
So they will get all the theoretical detail and coding part from the notebook.
Okay, thank you very much, sir. I will definitely share to all our participants. So if you have any question, participants, you can ask, sir.
Yes, sir. I have some question. If you give permission, let other ask, then I will ask, sir. If anyone wants to ask.
Yes, madam. You can ask now. No problem.
1 minute. Lot of dogs are crying over there. 1 minute.
Madam, you mute yourself.
Hello. Yes.
Yes,
I have a
madam.
question, sir. Sir, in the notebook and also in the Kaggle's data set, what you have shown over there, how to download the output from there, means the pictures or the graphs.
All the details are there in the notebook. You can follow the steps. Everything is there in the theoretical detail. If you check, all the details you will find. I will email the notebook to the organizers. So all the steps has been explained there. I just showed how to execute the coding portion because not much time was left. So all the step-wise details are given there. So you don't have to.
Another question, sir. Whether this Google Colab is uniform for everyone, or I have to buy or any other thing?
No. It is freely available. You can easily open it.
Okay. Data set to pursue deep learning.
All the Python and Pythonic platform you will be able to run in Google Colab freely. You don't have to buy anything. Okay, so you can easily run the course, machine learning, deep learning related course, reinforcement learning related course, but make sure the platform is either Python or Pythonic, like Keras, TensorFlow, PyTorch, MXNet, any framework, you can run it quite smoothly in this framework, Colab.
Thank you, sir. Thank you.
Most welcome. So I am just repeating the participants, respected participants, kindly do not worry. All the theoretical details, all the steps, everything has been explained in the notebook. Okay, once you load them, you will be able to see some text portion is there. Kindly follow it. All the steps are given there. And the coding portion, you will get the code. Okay.
Okay, so any more questions from the participants? Any more questions? Okay, so sir, now I am sharing my screen. So, sir, please accept this. This is I hope you can see that this is a token of appreciation from our side as organizing team. Please accept that in this online.
Thank you very much. Thank you. You can send me it over in my Gmail.
Yes. Okay, after this session, I will send.
Okay, sure. Thank you. I love the design. Thank you very much. Thank you. Thanks a lot. Thank you for all your
Thank
efforts.
you, sir.
And I must appreciate all of your efforts during this hard time. All of you are doing great by organizing this kind of the AICTE ISTE and pressure courses. And thank you very much for giving me the opportunity. Thanks a lot. Thank you. Thanks
Okay,
to all
okay.
the participants for their patience as well.
Thank you, sir. I hope you have also another session Monday, 12 p.m. So
Yes,
we'll
exactly.
meet again with you.
Again, yes.
Okay, okay.
Thank you.
So I will definitely mail you that, and all the documents what you will give to me, I will definitely circulate to the participants.
Sure. Thank you.
Okay. So now, host, you can end this session.